The ratios of the sides of a right triangle are called trigonometric ratios. The most common three are sine, cosine, and tangent. On the left, we have a triangle with angles A, B, and C and sides of measure x, y, and z. For terminology purposes, let's review all of these different things. So the hypotenuse for a right triangle is always the side that is opposite the right angle. So the right angle is at angle C. So the hypotenuse then is Z. We also refer to sides as being opposite or adjacent to different angles. So if we are looking at angle A, we can say that opposite to A is side Y, and adjacent to A is side X. Likewise, for angle B, we can say that side X is opposite to B, and side Y is adjacent to B. Now that we have that terminology out of the way, let's get into what sine, cosine, and tangent of angles are. There is a very useful mnemonic that really helps with this. You've probably heard it before, but if not, it is SOHCAHTOA. SOHCAHTOA essentially stands for sine equaling opposite over the hypotenuse, cosine equaling adjacent over hypotenuse, and tangent equaling opposite over adjacent. You can use those three trigonometric ratios to help you solve for either an angle or the length of a side, depending on the information that you're given. If you're solving for an angle, it is often helpful to know what the inverse trigonometric ratios are. Essentially, an inverse sine would be abbreviated as sine to the -1, which isn't taking it to the negative first power, it's just calling it an inverse. So the inverse sine of opposite over hypotenuse will give you the measure of an angle theta. That being said, let's do some problems down at the bottom to help really solidify some of these ideas. So we're going to use the triangle above, and we'll assume that it's not drawn to scale because the values are going to change. All that's really consistent about it is that C is going to be the right angle. What are the sine of A, cosine of A, and tangent of A? So if we think about SOHCAHTOA, we know that the sine of anything is going to be opposite over hypotenuse. So the sine of A is going to be equal to opposite, which is y, over the hypotenuse, which is z. The cosine of A, if we remember the ka in SOHCAHTOA, is going to be adjacent over hypotenuse, so that's going to be x over z. And then the tangent of A, or TOA, is going to be opposite over adjacent. So opposite is y, and adjacent is x. So the tangent of A is y over x. If x is 3, y is 4, and z is 5, what is the tangent of B? Alright, so tangent of B is going to be equal to opposite over adjacent. So opposite B, we have x, and x is 3, and adjacent to B is y, and y is 4. So the tangent of B is equal to 3/4. If x is 5, y is 12, and z is 13, what is the cosine of B? So the cosine of B is going to be adjacent over hypotenuse. So adjacent to B is y, and y is 12. And the hypotenuse is z, which is 13. So the cosine of B is 12 over 13. If x is 6 and the measure of angle A is 40 degrees, what is z to the nearest tenth? So we're given angle A is 40 degrees, and we're given x, which is adjacent to A, is 6. Which trigonometric ratio uses adjacent? Well, that's cosine. So if we have the cosine of the angle, so the cosine of 40 degrees, is equal to adjacent, which is 6, over hypotenuse z, we'll get the expression the cosine of 40 degrees equals 6 over z. So let's multiply both sides by z and divide both sides by the cosine of 40 degrees, and that way we can isolate z and solve for z. So that gives us z is equal to 6 over the cosine of 40 degrees. And we'll put that into a calculator to figure out z. That gives us, to the nearest tenth, 7.8. If x is 2 and z is 5, what is the measure of angle B to the nearest tenth? So x is opposite to angle B, so we should use sine, because sine is opposite over hypotenuse. So the sine of B is equal to opposite, so 2 over hypotenuse, which is 5. We want to solve for b, so we'll take the inverse sine of 2/5. So b is equal to the inverse sine of 2/5. And plugging that into the calculator to the nearest tenth, we get 23.6 degrees. If z is 6 and the measure of angle A is g degrees, write an expression using cosine to solve for y. So we're given the hypotenuse, which is 6, and we're given angle A is g degrees, which is a variable, not a number, and we want to solve for y using cosine. So using cosine, that means we need to have the cosine of an angle measure is equal to adjacent over hypotenuse. So adjacent, we have to assume is y, because we want to solve for y, over the hypotenuse, which is 6. Since y is the adjacent side for cosine, that means we have to be using angle B. So the cosine of B is equal to y over 6. However, we don't know what the measure of angle B is. However, we do know that the measure of angle A is g degrees, and we also know that the 3 angles of a triangle add up to 180. We know that angle C is a right angle, so that's 90, so we're left with g and an unknown. Together, they have to equal 90 degrees. So if we write angle B in terms of g, we would get the cosine of 90 minus g is equal to y over 6. Then to isolate y, we'll multiply both sides by 6. So that will give us y is equal to 6 times the cosine of 90 minus g. And that is our expression.